The next topic I want to talk about are these special guys. Now these special guys don't look like the other ones that we just did for video 1, 2, and 3. Look at this guy. There's only one set of parentheses. What makes it different is that it has an exponent on the outside. Now, some of you are probably going like, oh, I've seen these problems before. Isn't this the power rule where I just distribute this 2 to all exponents and then distribute to any negative signs? No. You might be saying, wait, why is it no? It just looks like it. And the reason why is because how many terms are in here? 2. Remember, I told you power rule only works with monomials. We got a binomial. So how do we handle this problem when it's a binomial? Then I told you, what does squared mean? Squared means write out the base 2 times. So what's the base? Boom. The first thing this 2 hits is a set of parentheses. So that's your base. So write out the parentheses twice. Don't leave it blank. Put in 3a minus 5. 3a minus 5 in each of the parentheses. When you do that, you look at it and you say, by gosh, that's just the same thing as a polynomial times a polynomial, a binomial times a binomial. So I'll either FOIL it, if you like it, distributing, if you like it, or what I'm going to do, rectangle. And the reason why I do that is because they're not monomials. It's a binomial times a binomial. So remember the rectangle says draw a big rectangle. Has to have 2 rows. So let's split this in half. So row 1, row 2, and 2 columns. Column 1, column 2. Remember I do rows and columns. 3a minus 5. Since this is rows, put it where the rows are. 3a and a minus 5. And then these represent columns, so put it on top of the columns. 3a minus 5. So, let's fill in the individual squares. We know a, it magically becomes a squared. Why a squared and not single a? Because you're adding 1a on top, 1a to the left, 2 of them. And then what do you do with these coefficients? Multiply. Here, no a, 1a, remember, still have the 1a. 0 plus 1 is still 1, so you gotta keep the a here. Negative 5 times 3 is negative 15. Remember, each of these squares is gonna have a's. Only this bottom corner, only one corner, will be a constant. This times this, 1a on top, none over here, still have the 1 on top. And then 3 times negative 5, negative 15. And then this times this, negative 5 times negative 5 is going to be a positive. 5 times 5 is 25. Now that you have the individual squares filled out, descending order, they're all a's, so that's good. I'll start with a squared first. Looks like that's the only a squared term. Then a to the first. Look, they line up diagonal. I said the majority, not always, but the majority of times they're going to line up. This is a negative. This is a negative. What do you do with 2 negatives? Collect. Tug of war. Same labels. Add. You get 30. A. Remember, only when you fill in the squares do we add. When you collect, A stays the same label. A. And then who wins the tug of war? It's a tie. So they both win. But notice both of them are negative. So make sure you put a negative. And then this is the only corner that's a constant. Now, if you're that person who said, I could have done that doing the power rule. This squared, maybe you get 9a squared. This squared, yeah, you'll get positive 25. But would you get the middle term, negative 30a? Unless you know the rules for this, a perfect square binomial, okay? That you know that the book says it's a squared times 2ab plus b squared. That's how the book wants you to learn it. I say, no. You could use that, which is the formula. Just realize, square. Write it out twice. Draw your rectangle. So you don't have to do first term squared, then this times 2, and then this term squared. Just do this. Do a rectangle. Much easier. Don't try to distribute. Just write it out twice, and then that's how you got your 3 parts to your final answer. So this one is one of the special guys. I'm going to give you another special guy. There's a couple special guys that I want to be aware of. You might have some problems that have more than one letter. All the ones that we were doing always had the same a's, maybe a squared, a to the first, but they're all a's. Here we're going to have one that has some letters that are different. See how this has a C and this has a D? So it's a little different. So it's a special guy. But once you realize this is a binomial and a binomial, it could have been a trinomial for all I care. But once you realize it's a regular problem, draw your rectangle. This is rows. This is columns. 5C. Put it over here, what's the rows? 3C. And the minus 2D. So let's fill in individual squares. C. Hey, they're the same. So 1C on top, 1C to the left, that means I have 2 of them. And then 3 times 5, 15. Now here, notice D, C. They're not the same letters, so you can't add them because they're different. So we're going to smush them together. Now how do we smush them together? Alphabetical. C, D, don't put D first, put C. You have 1C and you have 1D. So you can write it like this, or you put the little ones in, doesn't matter to me. And then 5 times negative 2. Coefficient times coefficient, you're going to get a negative 10. Here, same problem. C on top, D to the left. Put it in alphabetical order. We know we have 1D, we know we have 1C, but I don't want to do DC, I want to do CD. The reason why I emphasize that you want to put them in alphabetical order is because if you had one of them as CD, but if this said DC, these are technically the same, even though they're out of order. So if you always put in alphabetical order, then they'll always look the same. And then 3 times negative 4, the 2 coefficients multiply, get negative 12. And then here, D and D, they're like 1D on top, 1D to the left. That means I have 2 of them. And then negative 2, negative 4, you're going to get a positive 8. Now how do I put this in as my final answer? Alphabetical. So C first. What's your highest degree of C? Right there. So this is the only C squared term. Next, C to the first. So C's, we'll collect those. Notice they line up diagonally each other because CD, they're like terms. This is a negative, this is also a negative, so 2 negatives we add. So we're going to get negative 22, CD, remember when you collect, it stays the same variable part, same label, CD. And this, Now that we're done with the C's, after C is D. We already took care of these D's, so we don't have to worry about that. So I do D squared. It's the only D squared. So this guy technically doesn't have any constants. Sometimes that happens, especially when you have two letters like this. So this is your final answer, because C squared is not the same as CD, which is not the same as D squared. Let's show you a third type of problem. I think I spelled that right. Conjunctives. What are conjunctives? It's a binomial times another binomial. It's the same stuff, but opposite signs. See how this binomial and this binomial match almost, but they have different signs. One's a negative, one's a positive. We did one that was exactly the same with two of the same signs. When you have the same signs, the middle term will not disappear. When you have conjunctives, that means one with a negative and one with a positive, and the same items, you'll notice that the middle term disappears. We also call this difference of squares. Once you realize that you have a binomial times a binomial, you didn't have to recognize this as conjunctive. We'll learn conjunctives in Math 012 and 112 when we talk about imaginary numbers and i's. But for right now, we're not going to worry about conjunctives until you get into 012 and 112. And then we'll talk about this again when we talk about radicals. Radicals also has something called conjunctives. But for now, we can throw that out of our brain. Binomial times a binomial. FOIL, distribute. I'm going to show you rectangle. Big rectangle, two terms, boom, boom. Two rows, two columns, because it's by. That means 4 squares. This is rows to me. So 5W and a -7. This is columns to me. So 5W and a +7. So this and this, W on top, W to the left. That means I have 2 of them. Because remember, when I fill in the squares, I add those letters. And then 5 times 5, always multiply coefficients. This square. 7 times 5, we can do the numbers first. No W's, 1, so 0 plus 1, add to fill in a square, you got 1. This times this, if you want to multiply the constant and the coefficient first, you get -35. 1 W on top, none to the side, you still got the 1 on top. And then constant times constant, we'll get a -49. Remember, positive times negative. Because these are all the same letters, we start with the highest exponent. It's the only one that has a W squared. Then our single W's. But notice this is a positive and this is a negative. They're different. Different labels subtract. 35 minus 35 is 0. Don't even put W here. Okay, 0W, you got to realize 0W is the same thing as 0. No W's at all. So don't put any single W's here. And then this one, -49. This is what I was trying to say, that your middle term disappears. That you don't get the traditional trinomial, you get 2 terms. Difference of squares, we call this. So those are the 3 major types of special problems. So practice on these, and then you should be okay.